A network device is a hardware component that enables communication and data exchange between computers, servers, and other devices within a network. These devices are classified based on their specific functions in managing and directing network traffic. Below is an overview of commonly used network devices. 1. Router function. A router is a network device that connects multiple networks and directs data packets between them. It is primarily used to link a local area network LAN to the internet, ensuring efficient data transmission. How it works. The router receives data packets from connected devices. 2. It examines the destination IP address of each packet. 3. Using a routing table, it determines the most efficient path for forwarding the data. 4. If the destination is outside the local network, the router forwards the packet to the Internet Service Provider, ISP. 5. The ISP processes and routes the packet toward its final destination. Key features. IP address assignment allocates IP addresses to devices within the network. NAT, network address translation, converts private IP addresses into a public IP for internet access. Built-in firewall. Many routers include security features to prevent unauthorized access. Dual-band Wi-Fi. Modern routers support both 2.4 GHz and 5 GHz frequency bands for better wireless connectivity. Examples: home router provides Wi-Fi and internet access for household devices. Enterprise router handles high-speed data traffic in large organizations, ensuring network stability and security. Switch function. A switch is a network device that connects multiple devices within a network and efficiently manages data traffic. It ensures that data reaches the intended destination without unnecessary broadcasting. How it works. The switch learns the MAC addresses of connected devices. When a device sends data, the switch forwards it only to the intended recipient, minimizing unnecessary traffic. Unlike hubs, which send data to all connected devices, switches improve network efficiency by directing traffic intelligently. Types of switches. Unmanaged switch, simple plug-and-play device with no configuration required. Managed switch, provides advanced features such as VLANs, monitoring, and custom configurations. Layer 2 switch, operates using MAC addresses to forward data within a network. Layer 3 switch, combines switching and basic routing functions, using IP addresses for traffic management. Advantages: reduces network congestion by establishing direct communication paths, enhances efficiency compared to hubs by preventing unnecessary data transmission, supports VLANs, virtual LANs, for improved security and traffic segmentation. Hub, legacy device function. A hub is a simple network device that connects multiple devices within a network, but does not manage or filter data traffic. It operates as a basic communication point without intelligence for directing data efficiently. How it works. 1. When a device transmits data, the hub broadcasts it to all connected devices. 2. Each device checks if the data is intended for it. 3. Since all devices receive the same data, collisions can occur, leading to reduced network performance. Types of hubs. Active hub requires power and amplifies signals to extend transmission range. Passive hub simply connects devices without boosting signals. Disadvantages: no traffic filtering, making it inefficient for large networks. High collision rates, as multiple devices share the same bandwidth. Obsolete technology, replaced by switches for better performance and efficiency. Modem, modulator-demodulator function. A modem converts digital data from a computer into a signal suitable for transmission over telephone, cable, or fiber optic lines. It enables internet access by translating data between a network and an internet service provider, ISP. How it works. 1. The modem receives analog signals from the ISP and converts them into digital data for devices. 2. It transmits digital signals back to the ISP for communication with external networks. 3. A modem typically works alongside a router to provide internet access to multiple devices. Types of modems. DSL modem uses telephone lines for internet connectivity. Cable modem utilizes coaxial cables commonly found in broadband services. Fiber modem, ONT optical network terminal, Uses fiber optic cables for high-speed data transmission. Advantages: essential for establishing an internet connection. Disadvantages: requires a separate router for Wi-Fi and multiple device connectivity. An access point AP extends a wired network by providing wireless connectivity, allowing multiple devices to connect to the network without physical cables. How it works: 1. The AP connects to a switch or router via a wired connection. 2. It transmits Wi-Fi signals, enabling wireless devices to access the network. 3. Users connect to the AP using an SSID Wi-Fi network name for authentication and access. Advantages: expands Wi-Fi coverage in large spaces. Supports multiple devices simultaneously without signal congestion. Delivers better speed and lower latency than relying solely on a router for wireless access. Firewall, hardware-based. Function: a firewall acts as a security barrier that filters and monitors network traffic, blocking unauthorized access and protecting against cyber threats. How it works: 1. Uses predefined rules and policies to permit or deny data packets. 2. Analyzes traffic based on IP addresses, MAC addresses, ports, and protocols. 3. Prevents malware infections, hacking attempts, and DDoS attacks by blocking suspicious activity. Types of firewalls: packet filtering firewall, inspects packet headers to allow or block traffic. Stateful firewall, monitors active connections and permits only legitimate responses. Next generation firewall, NGFW, uses deep packet inspection, DPI, and AI-driven security to detect advanced threats. Advantages: provides robust protection against cyber threats, can integrate with VPNs for secure remote access. Gateway. Function: a gateway connects networks that use different communication protocols, enabling seamless data exchange between incompatible systems, e.g. a VoIP gateway for internet-based phone calls. How it works: 1. Translates data formats and protocols between different networks. 2. Serves as a bridge for communication between IoT, cloud, or industrial networks. 3. Can also function as a firewall, router, or proxy, enhancing security and traffic management. Example: a VoIP gateway converts analog phone signals into digital data for internet-based voice. Load balancer. Function: a load balancer distributes network traffic across multiple servers to enhance performance, prevent overloading, and ensure seamless service availability. How it works: 1. Continuously monitors server load to determine availability. 2. Directs incoming requests to the least busy server for optimal efficiency. 3. Improves redundancy and fault tolerance, minimizing downtime. 4. Commonly used in web applications, cloud computing, and data centers to manage high traffic loads. Types of load balancers: hardware load balancer, a dedicated physical device for traffic distribution. Software load balancer runs on a server, e.g. Nginx HAP proxy, to manage load balancing virtually. Proxy server function: a proxy server acts as an intermediary between users and the internet, enhancing security, privacy, and performance by managing data requests and responses. How it works: receives user requests and forwards them to the target website on their behalf. 2. Retrieves the website's response and delivers it back to the user. 3. Caches frequently visited websites to reduce bandwidth consumption and improve loading speeds. 4. Masks the user's IP address, enhancing anonymity and security. Advantages: blocks malicious websites, preventing access to harmful content. Bypasses geo-restrictions, allowing access to region-locked websites and services. A repeater or range extender enhances weak network signals, allowing them to travel over longer distances and improving connectivity in areas with poor coverage. How it works: 1. Receives a weak network signal from a router or access point. 2. Amplifies the signal and retransmits it to extend coverage. 3. Helps eliminate Wi-Fi dead zones, ensuring stable connectivity. Advantages: expands the network range, improving signal strength in large areas. Minimizes signal dropouts, ensuring a more reliable connection. Conclusion: network devices are essential for efficient data transmission, security, and overall network performance. Switches and routers serve as the foundation of wired networks, while access points and modems enable wireless connectivity and internet access. Firewalls and proxies strengthen security, while load balancers and gateways ensure optimal traffic management and seamless communication between different networks.